record, and we start with a quiz that we had. Let's see, problem number 43, something like that. I asked you to find so-called degree of that polynomial, and degree is called the largest power that I see among these four powers, and looks like the largest power comes from the second term, which is going to be 5. So we have the power of 5 polynomial because, again, the largest power of letter y was 5. So anyways, we encountered these so-called polynomials in section 5.1. What we did, we used to plug numbers in them. So if I try to do problem number 47, then in the 3-term polynomial with variable letter x, I'm gonna plug in negative number 2. So this is gonna look like 2 times negative 2 squared plus another number negative 2, and then add it with 2. So when you are asked to replace unknown with whatever number, then you just plug it in and calculate, see what comes out. And looks like in this case we'll multiply 2 by 4, and this is equal to 8. And you can see that this is exactly what they have for the answer. So I guess that's probably the most popular procedure to replace your unknown letter with some number inside the parentheses, right? So we also worked on the next section a little bit. In the next section, you calculate sums and differences of so-called like terms. So if I try exercise number 24 here, that says, how about if you take 16 y's and subtract 2 y's from it? Well, 16 minus 2 is going to give you 14 of those y's, and we just simplified. We so-called collected the like terms. We subtracted from 16 number 2. Well, how about exercise number 53 with minus 3 in front of the parentheses that I want to distribute? So we're going to have negative 3 times letter t, and then negative 3 times negative 5 is positive 15. And then we'll also do the same thing. We distribute negative 6 over this parentheses. So that'd be minus 6 times t, and also minus 6 times minus 2, which is positive 12. So once I have taken care of parentheses, because they have priority, then I will be collecting those like terms. So when I do this, I get a negative 3 minus 6, which is negative 9 times t, and then 15 with 12. When I add those, this be positive 27, right? So here we have the answer. Let me write this a little bit more careful. Minus 9 t's, and then minus number plus number 27. So again, nice feature of this textbook is that we can see the answers, and I hope these sections is something that you feel okay with, because adding and subtracting numbers is a favorite part. In the next section, they multiply and use the formula that if you have a to the power of n multiplied by a to the power of m, then what you do is add powers n with m. So that's a very popular formula in algebra. And when you multiply, let's say exercise 3, when you multiply -7 a power of 3 by another a, we can say it's power of 1, then all you had to do was to add the powers of letter a. So when you add 3 with 1, the result is 4. So we got the answer. So add in terms with same base terms that have a to the powers. So we say it's base a. We just need to add powers 3 and 1, and that's how we got 4. So this is, I guess, pretty much the only thing this section is talking about. So let us do some exercises at the end of this. And as usual, I go to the group of exercises called practice. So let me try to multiply exercise number 21 to start. So in this exercise, I multiply numbers separately. So when I multiply -6 and 4, I get -24. Now with powers of a, looks like I'm gonna get, let me write it actually, -6a squared times b is multiplied by 4ab squared. So I have to multiply numbers separately, get -24, and then start to add powers of a. So we have a to the first and a to the second. So if I add 2 and 1, this will give us a to the power of 3, right? And with powers of b is similar. So we have here power of 1 and 2. When I add these, I get also b power of 3. Please notice that sometimes they write multiplication the way like exercise 21 does. We have parentheses that separate those two factors. So instead of placing times like I did, they just put parentheses around those terms. And sometimes this is the way to go, because sometimes it's more convenient to use parentheses. But it still means that we actually multiply those factors with each other. So let me try exercise number 37 here. There are various powers present in this exercise. So let me copy this again. This is a +5a squared b cubed, which is supposed to be multiplied by, in the parentheses, there are 3 terms, actually 2 terms, 2a power of 4 times b minus another term, which is 5b cubed. So I'm going to have to distribute over these parentheses my first term and then the next one. So when I multiply those, I get a 10. 2 times 5 is 10. And then a will be raised to the power of 2 plus 4, right? To the power of a, I got 6, because again, we have added 2 and 4. So I just keep using this property above that says if you need to multiply 2 factors with exactly the same base, then all you do is just add those powers. So that's how we get a power of 6. And then b, I have the power of 1 and then 3. So we'll have 1 and 3, which is 4 minus. Now I have to multiply 5 and 5, which is going to be 25, right? A has no pairs, so I just copy it as a to the second power. And with b, I have power of 6. Again, this is because we need to add those powers of b, and they are 3 and 3, right? And we got the answer b power of 6. Right, be a little bit nicer. So anyways, that's how we do all problems in this little exercise set, even though there seem to be lots of exercises, but they're all pretty much the same. I want to say, how about problem number 57? Well, in this exercise, it looks like we have parentheses with x plus 2 multiplied by another parentheses that has also x plus 2. So I'm multiplying the same parentheses twice, and this is going to be a product of x with x, and that's in the first place. So we'll have x squared, and also I can multiply the last terms, numbers, 2 is a 2, and this will give us the number 4, right? Turns out that besides these two products, I also have to multiply on the outside x by 2 and inside 2 by x. So those two are so-called like terms. If I multiply 2x and then x times 2, which is another 2x, and if I put these together, I'm going to get a 4, 2 and 2, right? 4 x's. So this is the result. So we have so-called trinomial, and what I just did, I turns out foiled this trinomial. That's something we're going to do in this chapter a lot. So FOIL means I put a product of first terms, x's, on the first place, then terms on the outside and terms on the inside, and outside and inside I highlighted with white colors and got 2x and 2x that gave me 4 of those x's in the middle. And finally, last terms, 2 and 2, the product is 4. So this is the result. So you can always multiply like that, or you can multiply any way you like, because the answer is the same no matter how you do this process. So it looks like there are lots of little exercises in this section, but they all follow the same properties. Multiply expressions with each other, and that's about it. So let me try exercise number 65 here, which multiplies difference with the sum of exact same letters. So we have x plus 2 multiplied by, in the parentheses, x minus 2. So if I follow exact same idea of FOIL, in other words, multiply first, then outside, inside, and the last terms, that's where the word FOIL comes from, F-O-I-L, then when I multiply the first terms, x with another x, I'm going to have x squared. And then if I multiply the last terms, numbers positive and a negative 2, I'm going to get just a negative number 4. And the reason we don't have anything else is because the product of terms on inside and on the outside will cancel. Look at them. 2x on the inside and negative 2x on the outside will cancel each other. So there'll be nothing here with variable letter x. So we've got just two pieces, x squared and minus 4. And it turns out that we always have a product of two pieces, a result with two pieces. Let's say exercise number 67, you can see it's just a to the second minus b to the second, because we're multiplying the same exact terms, a and b, and in one parenthesis it's a plus b, and in the other it's a minus b. So the result is just a difference of two so-called perfect squares. So it's good to be familiar with this. It's very popular procedure, turns out, multiplying sums by the differences of the same exact numbers. So I guess this exercise section has a bunch of products that we get used to multiply, and I will move into the next section that does a little bit different type of procedure. Instead of simplifying, they talk about factoring. So what does this mean? Well, let's take a look at exercise number 17. We're in the section 5.4. This exercise says take number 24 and break it into factors. So I can write it as 3 times 8, because this number is in the timetable, right? 3 times 8 is 24. So 8 I can factor with 2 multiplied by 2 multiplied by another 2. And that's why people say it's going to be 3 factors of 2 here and 1 factor of 3. So altogether, they break my number 24 into the product of those little factors. So whenever you want to factor, you break the number with these little numbers that you cannot factor any farther. So that's the idea of the section. You want to write the number as a multiplication of factors. Again, it's not simplifying, it's actually making it a little bit more unpleasant looking, but the procedure is called factoring. So whenever you do this, then we get the result. So in the rest of this chapter, we're gonna get used to the process of factoring. So let me try exercise number 21 that wants us to factor number 128. Well, this number I can definitely divide by 2, so it'll be 64, right? So once I notice that I can divide the number by 2, 64 as a factor could be broken down to a pair of factors of 8. When you say, Alex, I want to factor it with 2 times 32. Well, you could also do it this way, but the end result is not going to change because each 8 factors with a pair of, actually with 3 factors of 2. So we can write it as a 2 and 2 and another 2 here. And as a result, I can see that we have 7 factors of 2 in our 128, right? So I broke the number with 7 same factors, and that's exactly what they want. That's called factoring completely. So you get this result. So please notice that this is a backward procedure compared to what we already did in the previous sections. So the factoring is kind of opposite to what we were doing before. So I guess today we need to start getting used to this procedure. So when I'm looking at exercise number 53, that has a pair of negative numbers, turns out I can factor out negative sign here. So if I have minus 5a and minus 10, then what people say you can do is take out negative 5 and then have a left from the first term and positive 2 left from the second term. And you can always double check and see if that works. If you distribute your negative 5 back, you will get indeed your original expression. And that's what you can do and see that the answer is indeed down below. And that's all we need in this exercise. So you take out whatever is in common, you factor it out. So I guess those are nice preparational exercises to do something like, say, exercise 65 that says, how about if you try to factor exactly the same thing inside the parentheses? So in exercise 65, where I have 4 multiplied by x plus y inside the parentheses, and then we also have a positive letter t multiplied by that same x plus y in the parentheses. Then what you can do is notice that this parentheses that has x plus y in it, you can factor out. So x plus y, I can put on the outside, and whatever is left over, such as a 4, and then positive t on the inside of this parentheses. So that's how we produce the second factor. And once I done with this, we finished, we factored that sum of 2 pieces. So take out what's in common. Let me do it once again, like in the exercise number 68 here. In exercise number 68, we have to factor 4 times x plus y in the parentheses. And also there's a t, so it's a positive t multiplied by x plus y also inside the parentheses. So it looks like the same x plus y is what I'm gonna take out, right? So factor out this parentheses, x plus y, I just write it only once, and then 4 and the positive t will give us another factor, another parentheses. So I just copy whatever is left over, and that's the answer. So again, notice that factoring is not simplifying my expression, but writes it as a product of pieces. So it's x plus y times 4 plus t, just like that. So anyways, how about if you try to factor the number for a little quiz, just to refresh how you used to factor everything, like 24 or 128. So how about if you factor number 100? Can you factor 100 for me. Factor it all the way down to prime factors such as 2 or 3 or 5 and produce the answer. So let's say if you want to write it as some 2 squared, you can say 2 to the power of 2. That's the way to go. So 2, and then this little so-called caret tells that this is a power, or you can write 2 power of 2 with words and put this in the Zoom chat instead of 2 squared, because I know that to write down something squared in the chat will be not that simple, right? But you could just use words. You could say just 2 raised to the power of 2 and whatever else. So the question is, how would you be able to factor such number as 100? So that's our little quiz for today. So please make sure you put the answer in the chat, in the Zoom chat, and that's the way to go.